Okay, so we're going to do this question, and it's basically prove this trigonometric proof question. And so, with proofs, what you can do is you can show that the left-hand side is equal to the right-hand side, or you can also prove that the right-hand side is equal to the left-hand side. And the way this is set out with this being on the left-hand side, it's almost suggesting that we should do left-hand side and manipulate it to get the right-hand side so as to prove this. But the thing is that it's really hard to break apart a fraction, whereas it's not as difficult to force a fraction to come into existence. So I'm actually going to take the right-hand side, and I'm going to see what I can do with it. Because it's relatively easy to force a fraction to appear, and I'll show you how. So take the right hand side, which is just 1 plus sine theta cos theta, and we're going to somehow manipulate this and try and get the left hand side. So we want to force this denominator to appear, and how do we do that? Well, that's pretty simple. Let's just divide it by sine theta minus cos theta. We can't just do that because this is not equal to the right hand side now. So we have to multiply it by this as well. So now we're literally just doing 1 plus sine theta cosine theta times sine theta minus cosine theta over sine theta minus cosine theta, which is just multiplying by 1 essentially. So we can totally do this because this doesn't change the expression. Okay, so let's just go ahead and do this. So I'm gonna put this at the front, put this at the top, and we're gonna put it in brackets. Don't forget the brackets. And we have our denominator that we forced. So we can see that this denominator portion is already how we want it. So essentially all that's left to do is show that this numerator equals this numerator here. So we can just focus on the numerator. So I'm just going to write NB, and I'm going to focus on the numerator, which is this 1 plus sine theta cosine theta, sine theta minus cos theta. And let's just remember, write down what we want so we don't forget it. So we want to show that this equals sine to the power 3 theta minus cosine to the power 3 theta. So how can we manipulate this to get that? Well, let's first expand the brackets. So we have sine theta minus cosine theta plus this times this, which is sine squared theta cosine theta, and then this times this, which is minus sine theta cosine squared theta. So we want it in this form, and let's just see. So we have sine theta, we have cosine theta. If we convert this sine squared theta into 1 minus cosine squared theta, we're going to end up having a term here, which is cosine to the power 3 theta, which is what we have here. And likewise, if we do that for here, we're going to have a term which is in sine to the power 3 theta, which is what we have here. So let's do that. So we're going to copy this bit, but then we're going to use this identity, which is simply that sine squared theta plus cos squared theta is equal to 1. So this implies that sine squared theta is equal to 1 minus cos squared theta. So we can just do that substitution here. So instead of writing sine squared theta, I'm just going to write 1 minus cos squared theta, cos theta, which is just copied, and then minus sine theta, 1 minus sine squared theta. Okay, so we have that. And now we simplify some more. So we get cos theta minus cos to the power 3 theta, like I said we would, then we have minus sine theta, then plus, because negative, negative, so we have plus sine to the power 3 theta, and then we can notice that some of these terms cancels out, namely cos theta and minus cos theta cancel out, sine theta and minus sine theta cancel out, so all we're left with is sine to the power 3 theta minus cosine to the power 3 theta, which is actually what we wanted. So the RHS, the right hand side, is equal to sine to the power 3 theta minus cosine to the power 3 theta over what we had before, which is sine theta minus cosine theta, which is precisely equal to the LHS, so proved. Or you can write QED.